recording? Okay, what I did on the first lesson. Now, what I have done is that I have taught you what are prime numbers, right? Prime numbers has only how many factors? 2. Those who have more than 2 factors are called composite numbers. Very good. And I have also talked about odd and even numbers, correct class? Okay, and also whole numbers. Okay, the page that I stopped was at page 4. All of you turn. Remember, for number 1 to 100, I did from number 1 to 50. Remember? To see what are the prime numbers. Agree? Now, are 0 and 1 counted? 0 and 1 are not counted. Okay. Now, next, I want to talk about some notation here. Okay. Now, all of you look at the board. I'm going to talk about some notation here. Now, when you see something on top, 5 squared, what does it mean? 5 times 5. 2 times, right? What is 5 times 5? 25, right? Okay. Now, have you all seen this sign before? Yeah. What is this sign for? Square root. Okay. So, square root of 25 will be 5. You need 2 numbers, take up once. Is that clear? 2 numbers, take up once. Okay, all of you take up calculator. I want you to find the square root sign. All of you look at the square root sign. Okay, now, I want all of you to look at the curve of the square root sign is a cube root sign. Can you see that? Cube root. Cube root means, let's say, I have 5 cube. It means what? 5 times 5 times 5 is 1, 2, 5. So, if I have a cube root of 1, 2, 5, the answer will be 5. 3 times you take out once. Now, how to go to the function on top? Now, some calculator have the shift key, right? Some calculator have the second function key, right? Can you see? Second function. Now, you press that one, then you press this button, it will go to the top. Because there are not enough buttons on the calculator. Do you understand? Okay, can all of you key in shift button, then this will get to cube root. Then you key in 1, 2, 5. Do you get a 5? Do you get a 5? Yes, no problem. Okay. I want all of you to key in cube root of 27. Do you get a 3? Do you get a 3? Cube root of 27. Okay. So, do you know how to use a calculator for square root and cube root? Yeah, no problem. Okay. Now, let's look at page 5. All of you turn to page 5. Test whether a number is prime or composite, you have to learn a new concept called the square root. I think we already know it in our primary school, right? See that? Okay? Now, for example, 5 times 5 is 25. We say that the square of 5 or 5 squared is 25. If we do the reverse, we take square root of 25, it will be 5. We say that square root of 25 is 5. So they ask you some questions. Okay? Now, next, I want you to look at after the last paragraph of this section. To find out whether a number is prime or composite, we check if it is divisible by all the prime numbers less than or equal to the square roots. Okay, this method is called 12 division. Now, I'll explain to you how. Will that be okay? I'll explain to you how. Just take it as a fact first. Alright? Okay, now I want everybody to look at the board. Okay, everybody to look at the board. I'm going to tell you how to check if a number is prime or composite. Now, let's say I want to check whether 387, look at for example what? 387, is it prime or composite? Okay, now, can all of you key for me, what is the square root of 387? Is it a decimal?
Yeah.
Okay. Show me the decimal. 19.679. Right. So let's give it to one decimal place with 19.7. Correct. So this is 19.7. Okay, class? 19.7. Okay. Let's check all the prime numbers less than 19.7 or equal to 19.7. We start with 2, right? Remember the smallest prime is 2. That is what? 3, 5, then 7, 11, then 13, then 17, then 19. How come you don't consider 23? Because it's already bigger than this. Do you understand? Okay, I want all of you to calculate up. What is 387 divided by 2? Is it the whole number? No. Then take 387 divided by 3. Is it the whole number? Yes. So that means this is 1 times 387, 3 times 1. What is the calculator? 3 times 1. 129. So we already have a few combinations. So is this prime or composite? Composite already, right? You understand? Do not have to test everything. You just have to take the square root and test all the prime number less than this number or equal to this number. Everybody clear? Everybody clear? Okay, now let's take a look at another one. So we conclude that this one is a composite number. Everybody clear? That's how we test. Now next, 997. Okay, can all of you key square root 997? Show me your calculator. 31.6, right? I know, 31.6. Let's give it to one decimal place. Will that be okay? That means I'm going to test all the prime numbers less than or equal to 31.6. Okay, so I will have what? 2, 3, all these, right? Plus 1. Next one. 23, then 29, then 31, then that's correct. Because 47, all these are bigger than 31.6. Okay. I want all of you to test. You take 997 divided by all these. See, will it give you a whole number? Test every number there. Now, use a calculator. Can you be divided by all those numbers? If you cannot, that means this one is only one star, 997. Cannot have other combination. So is this a prime? Is this a prime number? Yes. So this is a prime number. Everybody clear now? Everybody clear now? Okay? Now I give one number, you test for me whether is it prime or not prime. Okay? Test for me this one. Prime or not prime? Not prime. Okay. First of all, we look at this, right? What is this answer? 11 for what? What does it mean? 11.4. Correct. 11.4. So we will test until this one, right? This side, right? Can it divide by 2? How about 3? Yes. What is it? This one is 1 times 129, then 3 times what? 43. So can you see this is composite? You understand? So this is how we use the trial division. Are you all clear now? Are you clear now? This is how we test whether a number. That means you don't have to go through all the numbers. Just test until your square root can ready. Everybody clear with what I'm talking about here? Yes or no? Okay, good. Now, so this is for your information. Okay? Can you all look at page 5? Look example 1. They tell you that 387 is a composite number, whereas 997 is a prime number. Are we clear? Are we clear? Okay, good. Now, next. Can we look at work example 2 on page 6? I'll go through that. Work example 2 on page 6.
Okay, good. Anybody still blur about the calculator? Okay, alright, now.
called the base. What's that? The base, that is down there. This number is called the index, or is called the power. Is that okay? Alright, now if you look at page 7, index notation, okay, if you have 5 to the power of 4, okay, 5 is the base and 4 is called the index. Now, index is the singular. The plural is what? Indices. Just like girl is singular, girls are singular. I mean, plural. You understand what I'm talking about? So, index is singular, indices are plural. Understand what I'm talking about? So, they mean the same thing. Huh? Alright, now, then, can you tell me what is this index notation? Don't answer, I don't answer. I said in index notation. 3 to the power of 8. This is called index notation. Now, if I write like that, this is called index notation. Understand? So this is called index notation. Now, once you see the word evaluate, what's the meaning of evaluate? Evaluate means what? Find the value of. That means you're supposed to find the answer. If I say evaluate 2 to the power of 5, you cannot give me 2 to the power of 5. You must give me what? 32. This is the answer. Do you understand? Okay? In maths, you must know some terms. Evaluate means what? Find the value of. Understand? You must give the answer. But if the question says leave the answer in index notation, then this is the index notation. Are you all clear with what I'm talking about? So if you read the question carefully, you cannot anyhow do one. Everybody okay? Alright, good. So that is index notation. Next, I'm going on to the next one that's the most important. That is called prime factorization. Okay, prime factorization. Okay. Now I will teach you how to do prime factorization of 18 first. Okay, and how to write that in terms of prime factors and index notation. Okay, everybody look up. Go look at the textbook because I'm going to choose one method. I'll explain to you why I choose that method. Okay, let's say I want to find the prime factorization of 18. What do I mean by that? Oh, look at that. 18. I always do this at prime. You can use calculator. You start with the smallest prime. What's the smallest prime? 2. 18 divided by 2? 9. Can still divide by 2? No. What's the next prime? 3. Good. Is that right? Alright, now so until is 1. Okay, so 18 is actually 2 times 3 to the power of 2. Right. 2 times 3 times 3. So this is called the prime factorization in index notation. You don't understand. Actually you can see that 2 times 3 times 3 is actually 81. Alright, now any number can be put in terms of prime factorization. Do you understand? I'm going to use this fact to do highest common factors and lowest common multiple later. Now we must secure our prime factorization first. Okay, can? Are we okay with prime factorization? Okay. I call this the ladder method. I something like a ladder. Is that okay? Alright, good. Now, then, can we look at work example 3? There are actually 2 methods, but I'm recommending method 2. I'll explain to you why. They say what? Find the prime factorization of 60. Giving your answer in index notation. Okay, let's do it. All the look at the box. Don't look at the textbook. It's all printed down there. First prime, what is it? 2, right? Now, if you realize that 2 cannot, then you go to what? 3. But can you start with the smallest prime first? Okay, so 2. Then what's the answer here? 30. Very good. 2. 15. Then 3. Then 5. Then 5. Then 1. So 60 is actually 2 squared 3 times 5. Can you see it? You multiply all this, you will get 16. Now, why did I say that I do not want to use method 1? But look at method 1. It's like Christmas tree like that. Okay, why do I don't want that? Let me explain to you why. Okay. So, because of your handwriting. And also because you brush off, they cannot see already. You understand what I'm talking about? For example, you see, I'll show you 2 times 30, correct? Is this correct? Okay. Then this one will be 2 times 2 times 15, correct? Then will be what? 2 times 2 times 3 times 5, correct? Now, can you see that it's 16 already the Christmas tree is like that? Now, what if I give you 6,000? You're going to until you cannot see anything. You understand what I'm talking about? It becomes a huge Christmas tree and it's a total mess. So I do like that. Whatever, okay? It's for actually neatness and also so that you do not make mistakes. Are we okay? Can we understand that? Now, do you agree that they're actually the same methods? Just that I design like that and this one I just spin out like that. That's all. But this is very cumbersome. Do you agree? Very cumbersome. Oh? So we don't use this, we use this. Okay, can? Can, huh? So, when we write like that, it means we are expressing 60 in its prime factorization. And it is given into index notation. Are we clear? Are we clear? Okay, huh? Alright, good. Now, next. Can we look at now book example 4, the last example, before I tell you how to do your homework and we're going to do it together. Because the first time I do my homework, I'm hoping that you don't know how to do it, okay, and present properly. And in secondary school, everything must be done in pen, except when you draw lines, which will be pencil. Okay, now let's take a look at example 4. All of you read the question first. Uses 2, 3, 1 centimeter cubes to make a cuboid. Each side of a cuboid is longer than 1 centimeter. Find the dimensions of the cuboid. Now, in primary school we learn cuboid means all the dimensions are the same. Length, breadth, and height all the same. Okay? Why did they say each side of the cuboid is longer than 1 cm? It cannot be 1 cm, then it will only be 1 cm cube. Agree with what I'm talking about? Oh? Okay, now let's take a look first. First of all, you go to 2, 3, 1. Now by looking at it, straight away you know cannot divide by 2 already. Agree or not first? Because it's not an even number. Okay, you try, divide by 2, can? Yes. Yes. Okay. What is the answer? Here? 77. So you know the next number must be 7, right? So what's here? 11. So 11, 11. That means I know 2, 3, 1. Look. 2, 3, 1 must be 3 times 7 times 11, right? Correct. Oh, I made a mistake. Cubes. Cuboid. I repeat. Cube is all dimensions must be the same. What about cuboid? Can all dimensions be the same? It may not be the same. Cuboid can be like this. Are we okay? Are we okay? Then they tell you, find the dimensions of the cuboid. So the dimension of the cuboid can be 3 times 7 times 11. Do you agree? Length times breadth times height. Okay, so if I want to draw this, right, maybe it will be, okay, 7 cm, 11 cm, like that. So this is my cuboid that I'm going to form. Do you understand? Of course, can it be 11 by 7 by 3? And doesn't matter, it's still the same cuboid. You understand now? The volume is still the same. Okay? So, are we okay with work example 4? We're expressing everything in terms of prime factors Then after that, we use it to solve the problems that we are given. Okay? Alright, good. Now, I'm going to teach you how to do your homework. First, take out your content page. All of you take out your content page. Those who have not gotten the file, don't worry. Get it done by the end of the week. Okay? Now, if you look at your content page, right? Now, can you see that on top there's this topic description? Can you see that? Topic description, and the next column is actually source or score. The source of score doesn't matter one because it will always be a textbook. So when you write the title, you can cross over. Understand? You can cross over the whole thing. Understand? Okay? So I want you to write down number 1. Today's date. Exercise 1A. Prime factorization. Write down. Under the topic. You can cross over to the other side. Where are your content page? Where's yours? Take out the topic. Yes, correct. Now, then, can you take out a piece of foolscap paper? Write down exercise 1A. Prime factorization. And then today's thing. All of you to do it now. Now, because this is the first exercise, I'm going to help you with the exercise. Understand? Huh? Can you use calculator? I will tell you how to use it. Have you done your title already? Where's your foolscap paper? Okay. Are we done already? It must be fast, huh? Once I say you do it, you must do it, huh? Don't wait 20 seconds and start doing it, huh? It's too late, huh? Everybody clear? Okay, and also for the exercise, I cannot be giving you everything. I will choose relevant questions. Clear? Okay, I want everybody to get this ready first. Why waiting for? Huh? Where is the foolscap paper? Don't have. Can someone donate to me one? I don't want such thing to happen. Okay, all ready, huh? Alright. Now, can all of you look at page 9? Question number 4. I don't want people to talk, I want people to listen to me. Page 9, question number 4. Before we do a question, don't just start doing it. You must read the question first. What do they want? Clear? Okay, what the question says? Find the prime factorization of each of the following numbers, leaving your answer in index notation. Can you see it now? Okay, now, I'm going to start with 4B. Now, don't do listen to me first. 7, 5, 6, right? Like that. Can you do per line? Don't draw by your hand. Use ruler and draw. Understand? Okay. Use your calculator. Form first. I'll teach you how to present that. Next one you present yourself. What do you think is the first prime number? 2. Okay, what's here? You must quickly tell me now. Okay? 3, 7, 8. Is that correct? So can still be 2, right? Okay, 2. What's the answer? 1, 8, 9. Now, down here you see cannot be 2 already. Divide by 3, can. Okay, what is that? 63. So can still be 3, huh? Answer? 21. Then 3 again, right? Then what? 7. Then 7 and then 1, right? This is the prime factorization. But this is not the answer yet. They say express in prime factorization in index notation. You must write 756 equals to 2 squared times 3 1. prime factorization in index notation. Are we clear? So this is what you do, plus, write down 4a, then you do, then you write down 756 by the side in your index notation. Are we okay? Are we okay? This one, I haven't finished. After you copy 4b, right, you are to do 4d. That means you leave a line. That means, let's say you 4a is not here, then you leave a line. It's not 4a, right? What is it? 4b, by mistake. Then 4d, right? Alright, then you do likewise. Can you tell us a number for 4d? 630. Can you do likewise? And then you give me the prime factorization by the side. Everybody clear? So, which one will you do first? 4b, then 4d. Now, the time now is 10, about 10, 15. I'm going to start the next one. Clear? Okay, do it now. Let you know what you should be doing. If let's say you read this They say, oh, can be 2. Correct. 35, then 5, then 7, 7, 1. You're not wrong. But can you see this is jumbled up? When you write, it will be 630, 3 squared times 2 times 5 times 7. Now, you can also rearrange. It doesn't matter. Do you understand? But what I'm worried is that some people do this. 3, 2, 3, 5, 7. Then, can you see you got to group these two together? It becomes 3 squared. That's why I say you go systematically from the smallest to the biggest, then it's easier for you. Understand? This is to simplify your life. Everybody clear? So, I want to ask the whole class, are you clear with 4B and 4D how to present? Okay, good. Next question that I want to look at is question number 6. All of you look at question number 6. Don't do just read first. Okay. Question 6 says, Cheryl uses 273 1cm cubes to make a cuboid. Like example 4 just now, right? Cube to make cuboid. Each side of the cuboid is longer than 1 cm. Find the dimensions of the cuboid. Okay. First of all, after, you see, it's a full step, right? After every part, 4B, then 4D, you must leave a line, then you do number 6. Understand? Okay, then don't divide into 2, not enough space. I don't want, you must turn to the next page. Okay, what do you want? No. Okay, now number 6. What is the number that is given to us? 273. Can you write this in prime factors first? All of you. You should know how to do it now. Answer? What's number? 3. Okay, what's here? 90? 1. Okay, then? 7. What is it? 20? 14. 13. Okay. Then 13, 1, right? Now, do you agree that all these 3 are prime numbers and it's bigger than 1 cm? Okay, now what did the question ask for? Now look at the question. What are the dimensions of the cuboid, right? So the dimensions, you must at least write a statement. Dimensions will be 3 cm by what? 7 cm, very good. By what? 13 cm. This is how you write your answer. This is not finding the volume, this is finding the dimension. If I want the volume, I must multiply, right? That will come later. They want the dimension, you must answer to the question. You don't get over and answer something else. Understand now? Are we okay so far with the 3 parts? This is the first homework, that's why I'm telling you. Next time I'll just give it to you, you do it yourself. I will show you how to present OD. But you must present properly. No unreadable handwriting. Let me tell you this. Okay? Alright, now next I'm going to give 2 more questions. And I'm going to give you 5 minutes to complete it. Okay. Can all of you look at question number 9? All of you look at question number 9. Find the prime factorization of each of the following numbers, leaving your answer in index notation. Now I want you to compare question 4 and question 9. Can you see that the question is exactly the same? What about number 9? What happens to the numbers? Much bigger. Remember to say that? Much bigger. Okay. I want to do 90 and 90. You do it for me. I give you 5 minutes and you tell me the prime factorization in index notation. I don't need the working out. Can you tell me what's the answer? 2 power what? 2, okay, times 3 to the power of 5. Any more? Times what? 7. Is that all? Can you all get this answer? Can you understand how I put it into prime factorization? Okay, let's take a look at the last one. Are you all done with the last one? Some of you are still doing it. Those who have done the last one, 2 to the power of what? 5. Okay. Then 3 cannot. Okay, 5 to the power of 3. Then 7 power 2. Any more? No more. So can you see? This is how we put it in terms of prime factorization. Are we all clear? Are we all clear? Okay. After you have finished 90, let's say your 90 is here, you draw a line, you say that you are done. Make sure you have written your name, okay, and your index number and your class. And don't forget, you must write exercise 1A, the title, and then the date. Alright, because I'm going to collect the work from our team. And how do I collect the work? I will tell you later. Okay, how do we get it done first? Once you're done, can you put your pens down so that I know you're done? Then I can collect the work straight away. Now, how I collect work is this. All those 2 persons in front, right? Hello? This one, there are 8 people in this column. From the back, we pass forward. This one, there are 6. This one, there are 8. This one, there are 8. Once you're done, you pass forward. Pass forward. Tell me the front row, okay? Eight, there we go, 8. Is that 8 for this row? Just count. Who is not numbered? Never mind, you count for me. I'll roll 7.
You do that.
对，是不对。这个不对，两个我不对。I have 2 more from this row. Okay. This row, how many count? 6. Thank you. some questions that is not usually the type of question that you get in the exam. Sometimes it does come out. Okay, look at question number 10. Take out the whole book. Later I want you to copy down. Now, hold on, look at the question number 10. Page 10, question 10. Page 10, question 10. I don't wish to repeat it. Given that x and y are whole numbers, such that x is less than y, and x times y is 0, 2, 2. You know that I can also put like that. It means x times y. Okay, it's 2, 0, 2, 2. Write down all the possible pairs of x and y. Now, what is the condition for x and y? X is what? Less than y, right? The question says so, right? Correct. Now, class, I'm going to tell you this. If you're going to do by guessing, you might miss out some numbers. Am I right to say that? Okay, now, I'm going to do the prime factorization. All of you do together with me with your calculator. If I divide by 2, what will I get? 1, 0, 1, 1. Of course, look at this number, you know cannot divide by 2 again. Divide by what? Times 3? Is it possible? Yes. 3 with what? 3? How many? 3, 7? No, 3, 3, 7. Okay. What's the next number? Can it be 3? No. 5? Of course no. 7? 7 also no. If 7 no, what should the next one be? 11. 11 can? No. What about 13? No. What's the next number? What's the next number? 17? No also. 19? No. What is the next number? 337 is the next number. Is it correct? How do we check if 337 is the next number? That means what I'm saying is that 337 is a prime number, am I right? Okay, now, remember just now I taught you this one? What's the square root of 337? 18.4. Okay, so I just need to try anything that's one number that's less than 18.4. So until 17 can, right? So you divide by 17 cannot. So you know it must be what already? 337, right? Then what do you get? 1. Okay. Now, this is the trick here. I'm supposed to put it in terms of x and y, right? Such that x is what? Less than y. Okay, good. So let us take a look at the question. Alright. If I have 1, I must answer.